Okay, so hi everyone. Happy to be here tonight. I have been working at Transit for the last 5.5 years, and we've been working on this project for the last 9 months or so. So I'm happy to talk to you first about Transit and then about detours before taking it over to or handing it over to Marisa, who can help us with methodology because it's complex. So if you don't know, Transit is an app. It's available on your phone. It was designed to get you around without the use of your own car. So I'm sorry you cannot drive to Milton using our app. Um, that means that you can see all of the options available to you, including buses and trains, but also bike share, ride hail, scooters where they're available. And you can find it in the App Store by searching for transit, the word, and looking for a green logo. We have almost 500,000 users in the GTA, and 300,000 of them are primarily looking for TTC information. Why did we get into the business of detour detection? Basically, we were frustrated with walls of text. As you can see here as an example, Metro Transit in Minneapolis provides us with a whole heck of a lot of information, but it's really difficult to parse. I don't know if you have seen the same thing happening in our app in Toronto, but we hate staring at huge blocks of text. Our app has been opened over 500,000 times so far today by TTC riders, and we wanted to get them the best information possible. We also thought we could help because we're already storing vehicle locations for all of the vehicles that you see in the app. And we have schedules we can compare to, we have trip information we can compare to. Basically, the data was in our fingertips and we could do something about it. What is automated detour detection? Well, it's looking at where the vehicle is, where we expect it to go, and when it doesn't go where we expect it to go, logging that and figuring out whether or not it's just somebody who ran into something at the last minute that caused them to turn right instead of going straight, or if this is going to take half a day and we should really be telling people about it. It's like remaking schedule information. The phrase you're going to hear regularly throughout this is the acronym is GTFS, which stands for General Transit Feed Specification. And it is the open data source by which we are able to perform all of this work. I'm happy to explain that more in the future, but for now, I'm going to talk about detours for TTC. This project, as I mentioned, started about 9 months ago. We were originally only looking at streetcar detours, and I just checked out what happened earlier today while building this slide, and we were detecting 6 active detours. 1 streetcar detour and 5 bus routes were affected. Over the past month, we've added detours to the app for over 100 unique TTC routes, which represents 50% of the bus and streetcar routes currently for the TTC. If you ask later what your favorite route is, I can look up quickly whether or not we detected a detour on it in the last month during the Q&A. And now I'll pass the mic to Marisa to talk through more about how we did all of this.
Thanks, Emily. Can you guys hear me okay? I'm going to assume yes until I see something saying otherwise.
We can hear you, Marisa.
Okay, cool. I didn't check my audio before, so. Okay, I'm going to talk a little bit about our methodology. I'm going to keep things really, really high level because I know we're on a tight schedule. And then we're going to talk through some specific examples that show where our detections work really well, and also talk through a few cases that we're working on currently to try to improve. So we're going to start with a simple example. Like Emily said, we can see from the TTC, they do try to put their best to put out information to communicate detours to riders, but it's a lot of text. It can be confusing to parse, and you have to know to go and check the information. Plus, we have cases where you might not even get this. If there is an unplanned detour happening. TTC might not have had time to put any information out about the detour, and suddenly your bus is going somewhere that you didn't expect, which is probably an even worse experience. So how do we get from this to something that is pretty easy to digest and is in a format that is ingestible by our app and also possibly usable by other people like transit agencies themselves? Okay, so to start, we have in our backend, like Emily said earlier, the ability to track in real time vehicle locations. So we're able to have a tracker that sees when multiple consecutive trips appear to have skipped some section of a route going in one direction. So when they think that some vehicles appear to not be serving, stops in this area of the route, then we launch a script that then checks to see if there is in fact a detour happening in this location. In that script, we load the vehicle data from recent trips around the area of the suspected detour. We do some cleaning of these GPS points, and then we have the image that's shown on the top right of this slide. The black line and the black dots are the route and stops, and then the blue dots are GPS for a single vehicle along this route. Then we use a map matching algorithm we've developed that aligns the GPS to the street network using OSM, which is OpenStreetMap. So we go from these dots to a nice line. And for streetcars specifically, we limit the map matching to only match to the streetcar network that's mapped in OpenStreetMap, because obviously we don't want to be sending a streetcar down a road that does not have tracks for it to go down. Okay, so how do we then get from this nice blue line we have, the vehicle has been matched to the street network, but now we need to figure out what portion of this path that the vehicle took was actually the detour and what stops did it skip along the route. In this case, that looks really easy to do, but it's not as simple as just a difference in shapes, because we also have to account for directionality of the route and the direction that the vehicle is traveling. So if the vehicle is traveling west on one direction and the route is meant to go east, that actually shouldn't be considered that the vehicle is serving those stops, because it's going in the opposite direction it should be. And we have to account for weird quirks that happen in specific agencies, like routes that actually do loops or detours that are doing loops, and other strange things that happen. So once we have figured out the detoured portion of the route, which I'm showing here in red on the slide, we figure out what section of the route was skipped by the vehicle on this detour, and we use that to find the skip stops. And then we take all this information and we format it into the trip modification spec for the GTFS, which allows it to be consumed not only by our app, but also by potentially other consumers. Then we periodically monitor this detour and we check for changes in the detour shape. This is particularly important for detours that are unplanned. And then when we think that we see vehicles back on the route, we do a confirmation to confirm that the vehicles are indeed back on route, detours over, and we remove it from the app. But like I said, this case I just walked through is very, very simple, and this can all get way more complicated than it seems. So like I mentioned, one example is multiple paths taken for the same detour. How do we know which one is correct? You can think especially of a case of an unplanned detour. Buses just might start detouring. They don't have directions from anyone on what direction to go. And everyone might be taking a different path until they converge to something. So in that very beginning stage, especially, we have to be smart about which one we choose to show in the app. It could also be that some vehicles just don't even follow the detour, or they skip different stops. Again, very common in an unplanned detour. We could also have inaccurate route shapes in the GTFS or stop locations in the GTFS. So that can lead to false positive detours or us incorrectly canceling stops. You can think, for example, there's some cases where a route shape doesn't actually follow directly the road network, and we think that a detour is occurring when in fact it is not. We can also have really bad GPS data. This can be from just regular inaccurate GPS data, especially like in downtown corridors, but also specific agencies have different ways that they maybe snap GPS to a route, which obviously makes it hard for us to know if there's a detour happening or not. And there's other quirks that we've had to work through with that. We also have route loops I mentioned. And then we have two cases I'll talk about a bit more in the upcoming slides, which are split routes and start and end of line detours. Okay, so now let's look at some more interesting, challenging cases. So in this case, this is a screenshot from an internal dashboard that we had to help us monitor detours. So the black line here is the route, red are the skip stops, and then the green line is the combination of like the route and the detour. So it's basically the path that the vehicle is taking overall. And it looks pretty good, but if you look a little bit closely, you notice that there's this little line that sticks out and appears that the vehicle is like doing a U-turn and then returning to a route. So we thought that looked a little bit strange. So we looked a little bit deeper into it. Emily, if you could click ahead. One more, thank you. So we looked at the raw vehicle locations for that day, and we can see that they're taking actually a different path than what we routed them to on the detour. So we can see that the vehicles travel down University and then they just go, they go down University and then left on Queen, and we are not routing the detour down University. So we were like, that's strange. Why is our map matcher giving us this weird result? But the reason that's happening is because this is a streetcar route. This is the 501 streetcar. And if you go to the next slide, there's no streetcar route on University where all the vehicles appear to be going. So how is this possible? Well, the vehicles are actually buses running a replacement service, not streetcars themselves. But in our data, they're labeled as streetcars. So because we think they're streetcars on our end, our map matcher winds up with this weird thing that tries to do the best it can to align, find a path through the GPS points that conforms to the streetcar network in OSM. And we get this weird little U-turn happening. So this is something that we've run into, something we've talked to TTC about to make sure that we're getting the most accurate data we can so that we put, the best results in the app that we can. Okay, next slide. This is a case specific to TTC, I think, where the TTC will sometimes split a streetcar route instead of doing like what I would call like a normal detour. So in this example for the Toronto International Film Festival in September, the 504 streetcar was split. So we had, instead of one line going, one direction, we took a section out of the middle. We have like a left and right section of the 504, and then we have a replacement bus service that serves between those two segments of the 504. So this is confusing and really not well set up for our system to detect currently. And why is that? Well, if you look at the next slide, these are all of the vehicles that we have for the streetcars on September 6th on this route. So we can see that they aren't serving the split section of the route. That's the black line that's running, where Emily's showing. So we have all of these vehicle paths. We can kind of see they're not on the route, but we can't see from this, like all these vehicles are tagged with the same ID in our data, and we can't see that they're actually serving, in some ways, three different segments, like the right segment or the east segment, the west, and also the bus replacement. So the way our system works and the way that we're getting the data from the TTC in this case is really difficult for us to parse out exactly what's happening here and put it in a way that's presentable to users. So this case is difficult, but hopefully we're going to be working with TTC to handle cases like this at some point. And then finally, a more general issue we've had not only with TTC, but other agencies as well, is handling start and end of route detours. We do a pretty good job, but I just wanted to explain why these are more challenging than our traditional detour that I explained at the very beginning of this section. So this example I'm showing here is the 202 bus going to Cherry Beach. Normally the bus would go over a bridge and go all the way to the beach, and then turn around and go back the other direction. But in this case, there was bridge construction and they couldn't go all the way down to the bridge. So instead, the bus goes down Cherry Street, down Commissioners, and then up around to Lakeshore Boulevard, and then back and continues the other direction. So that's the image that was posted by the TTC. And then the two images on the right of the screen, we have what we detected for the east and west directions. And in this case, we did a really good job, which is exciting for us. But the reason this case is difficult is there are cases of start and end of route detours where the vehicle won't actually leave the route at all. So we can think of an example where instead of doing this little loop where the vehicle goes down Commissioners and Lakeshore Boulevard, maybe they just go down Cherry Street, go into a parking lot or something, turn around and go back. And that's really difficult for us to detect because the exact point of where vehicles switch their correspondence of what direction they're serving on the route can vary from vehicle to vehicle. So it's hard for us to know exactly what is the stopping point along this route. And similarly, in this case, even when vehicles do leave the route, again, figuring out where one direction is split into the other direction is challenging for us. So in this case, we did really well, but you can think, as the vehicles are going along Commissioners and Lakeshore Boulevard, different vehicles might be switching their directions from, east to west at different points. And it's really hard for us to know where is one direction split into the other and how do we display this in the app. So in summary, detour detection on its surface, we can show you all the really pretty images and make it look really easy. And in many cases, it is, we do detect things correctly and we detect nice, clear detour paths we can show to users, but we also have all of these edge cases we're working with, and we're excited to keep working on them and fixing those to provide the best experience that we possibly can for riders in the TTC and also everywhere eventually. And that's all.
Thanks. I think we're ready for Q&A. Should I stop sharing? Should I keep sharing?
Can you hear me now?
Yes. Wait, there's an echo.
You're going to have a brief break while I stop talking and the echo goes away.
Give us 2 seconds. This is completely my fault.
Switch the audio.
Let's make it come out of that computer that the mic is also going.
Make it come out of the actual computer?
Yeah.
Okay.
Or we can connect it to the HDMI. If you yank.
But then I have to
HDMI
pull,
out that
okay,
one.
pull this out? Okay.
No, I don't want to mess anything up, but maybe I will, maybe I won't. Can you hear me now?
We need someone online to speak in order for it to come out.
Okay. Can you hear us online?
We can hear you, Jamie.
Oh, and we can hear you. Okay, perfect. We're doing really well. Can I just say thank you to Emily and Marisa then for a fabulous presentation. Well done. Really interesting. Big round of applause in the room. I'm very grateful also for you bearing with us while we have our little glitches. We're testing new stuff. That was really, really interesting. How to make something unbelievably complicated actually turn into something simple and useful for people, like amazing. We're going to do some questions now. We've got a few minutes. We're going to ask people if they have a question online, if you could drop a letter Q in the chat, that would be great. I can see they're already coming in. And then if you've got them in the room, you can just pick up your hand. We are put up your hand. We are going to go online first. Luke, who have we got online?
We have Tom. Tom, you can unmute and ask your question. No problem, Tom. We can come back to you. KJ.
Yeah, what's going on, guys? So it's really cool that so basically I'm actually more grateful that I'm at this event because right now I'm actually going through a project outline for a luxury rental app, right? So there's different vehicles. So basically clients come in, they can rent all different vehicles, they could choose the service type, and then they could choose the waypoints on their itinerary, and then just the managing of all that, right? So like seeing what you guys did right, at a much bigger scale, right? Obviously, I would definitely love to connect with you and get your experience so I don't make the same mistakes that you might have made. Not saying that you made mistakes, you must have been perfect, but I'm not perfect. I might make mistakes, and hopefully you guys can help me out. But one question one question, if I might ask, is right when it comes to have in your app, is there I don't think I understood it too well. If I don't think it was understood it too well, but there so you have an itinerary. Do you if there would be an itinerary almost or like a waypoint, maybe if you use different terminology for it, can you track when the streetcar, right? It's not a bus car. I think it's a streetcar. It's not a bus, it's a streetcar, gets to a certain destination, or just real-time tracking of the whole itinerary. Um, right. I just want you to go over that and elaborate that and like, what solutions I should use if in this project that I have here.
First, I think you should download the app. I think that a lot of your questions can be answered just by opening the app wherever you are, and I assume that you're somewhere that we operate because we're in like 500 cities. And we do track in these screenshots the locations of the vehicles. This is the number of seconds that we last got information from the vehicles themselves, and you can see where the vehicles are on the map. So yes, is the shortest possible answer to your question.
No, like what software? Like,
Sorry,
Oh,
sorry, we're
okay.
going to have to move on. Sorry, KJ, we don't have too much time, so we're going to move on if that's all right. Thank you, Emily. Tom, how are we doing? Shall we go back to Tom, Luke, do you think? If that's a...
Tom, are you able to unmute? Sounds
Yep,
like it.
I think so. Okay. So, first of all, thank you so much for not gatekeeping the your results within your app and willing to share back to everyone else through the GTFS, I believe. So thank you for that. My question is, what's your experience working with like TTC and how does it work? Like, are you paying them? Are they paying you? Like, what's the just want to just on it.
They are paying us a small amount of money for this pilot project. The project length is a year from the time that we launched it in the beginning of September or end of August. I'm trying to remember. And so, yes, they are paying us for access to the GTFS trip modifications feed and for it to appear within the app.
We're also continuing to work with them to like evaluate how we're doing, addressing edge cases, putting in metrics in place that will allow them to see like, is this a successful project or not? So it's a lot of work.
Cool. And of benefit to both them and us as users, I would imagine.
Yes, absolutely. Yeah. I just want to be clear. It's not like a one-time thing we launched where like it's an ongoing relationship with them.
Excellent. Okay, we're going to go in the room now. I see Dylan has a hand up, and then we're going to come to Cam after that.
Thank you so much for the presentation. It was really well organized. I guess just it, always feels a certain way when you're living in a city, but what are you guys seeing going on with transit, in aggregate with the data?
The data around detours?
Yeah, just overall, like what sort of trends and stuff. I mean, obviously, for people on the ground floor, it always feels like everything's getting worse all the time. And, what are you seeing with an actual 1,000-foot view?
I'd like both of us to answer this. Personally, I'm mostly excited about the number of opportunities that this has been able to unlock for us over the last several years. I have helped 3 agencies move to providing real-time data in GTFS RT standards over the last 12 months. And one of them is the TTC. And that's been a really validating experience, not only for the quality of open data standards and how far we've come from when I first started and also when transit was founded. It was a battle when I first started, but also 10 years ago to even get this information from transit agencies. They were very suspicious of putting their schedule information, their real-time information out into the world. And now we have the opportunity to do really interesting and cool things with it, which we did not have at the beginning. We were just like scraping websites for schedule information. And now like I'm able to talk to the TTC about like how to get this data in more hands. And that's really cool. So that's my bit. But Marisa, I'm curious to know what you think.
I don't know if I have much to add to that, Emily. You had a good answer. But I think we're also really biased, right? Because we work every day with agencies and internally to try to make all of these improvements. So we see all of the good steps that we're taking. So it's maybe opposite of what an average person riding transit might think is going on. So yeah, I don't think it's all doom and gloom.
No, this is the fourth implementation that we've run for detour detection.
Yeah.
And each time we do one of these projects with a different transit agency, we learn like just that much more about how this data can be represented and how it can function.
Yeah.
And everybody has their own weird use cases that no one else uses. I'm shocked.
Yeah, we also didn't really say in the slides, but the project started as the detours project overall started as a collaboration between us and the STM in Montreal, and it has grown from them to try to expand to other agencies. But yeah, like Emily said, like we focused on a very specific use case when we started, and now we're finding all these edge cases and ways we can make it better so that eventually, hopefully, we can have it in as many places as possible.
Awesome. We have got time for one more, I think, so Cam.
All right, I have a question. Do you have any ambitions to tackle the most disruptive of disruptions, subway shuttle buses?
Oh.
They're so hard. They are, it's something that I regularly want to try to figure out, and we've done a little bit of work with the TTC. Like they do really try to do replacement bus service and put out extra GTFS every time they do it. It's so hard to base real-time information off of not static information, and know when it's not just like a vehicle deadheading or a vehicle like with some operator who hasn't switched their transponder, and like it's it's so hard. I aspire to that one day, but we haven't figured it out yet. Marisa, do you have further thoughts?
I was just gonna say, if we showed like every vehicle that existed, like regardless of if we thought it was on a route or not, it would be chaos. So yeah, we need some work to be able to figure that out.
Well, you've always got to have something to aim for, haven't you? And we can dream. We can dream. I'm afraid, I know there are other questions in the room and online. That is all we have time for, I'm afraid. Can I say thank you again to Emily and Marisa for coming?